Hello, I welcome you into Kenya Mathematics Classroom. And on this particular platform, now we are going to look at the part 3 of Binomial Theorem. If you are watching us for the first time, I would advise that you go back to the platform Kenya Mathematics Classroom to watch the part 1 and the part 2 of the Binomial Theorem so that you can appreciate what we are going to do. In this particular episode, we are going to solve these questions and we are asked to expand the following in ascending powers of x as far as the term in S cube. This is very important, so take note of this. We are asked to expand the following in ascending powers of x as far as the term in S cube. Then the first one, we are asked to expand 1 plus x exponent minus 2. We have 1 plus x exponent 1 on 4. Then we have 4 plus x exponent half. So when you look at this, you realize that the exponents, these are not definite integers. Therefore, we are supposed to use the expansion 1 plus x exponent n. If you remember, this is the same as 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1, n minus 2 over 3 factorial x cubed plus up to xn. So don't forget that we have to expand as far as the term in s cube. Okay, now the first question, we have 1 plus x exponent minus 2. Now, when you look at this, when you compare the two, you realize that you have 1 here, your x is your x here, but your n is now minus 2. That means in this expansion, wherever you see n, you substitute that by minus 2. So we are going to have 1 plus n is now minus 2. So we have minus 2x. Then you have n, and the n is minus 2, n minus 1. That is minus 2 minus 1 over 2 factorial plus n. And n is minus 2, n minus 1, that is minus 2 minus 1, n minus 2, that is minus 2 minus 2 over 3 factorial. Then we have x cubed. Don't forget that we are asked to expand as far as the term in s cubed. So when we get to the s cubed term, we have to stop. If it was the term in x exponent 4, then it means we have to continue. But from the question, we are supposed to expand as far as the term in s cubed. So when we get to the s cubed term, then we stop. Now we simplify this. We have 1 plus, don't forget we have minus 2 times x. So it is 1 minus 2x here. Then we have plus. In here we have minus 2. Minus 2 minus 1 is minus 3. 2 factorial, don't forget, is 2 times 1 plus. Then here we have minus 2 minus 1. We have minus 3 here. Minus 2 will give us minus 4 here. Don't forget again that 3 factorial is the same as 3 times 2 times 1. Then we have our s cubed here. Okay, so a step down, we have 1 minus 2x. Then we have, don't forget that here we have our x squared here. Okay, so we have x squared. We have our x squared here before the plus. Okay, so we also have our x squared here. So minus 2 times minus 3 will give us plus 6. Then we have our x squared here, all divided by 2, because 2 times 1 is 2. Then minus 2 times minus 3 is 46. Then 6 times minus 4 is minus 24. So we have minus 24. You have your s cubed here, all divided by 3 times 2 is 6. 6 times 1 is 6. So we have divided by 6. So a step down, we are going to have 1 minus 2x. Then 2 goes into 6 3 times. So we have plus 3x squared. Then 6 goes into 24, it's 4 times. So you have minus 4s cubed. So this will be the expansion for 1 plus x exponent minus 2. This will be the expansion for 1 plus x exponent minus 2. Don't forget that we have to expand as far as the term in s cubed, and that is why we have to stop here. So it's all about the formula. That's 1 plus x exponent n equals 1 plus nx plus n minus 1 over 2 factorial s squared plus n minus 1, n minus 2 over 3 factorial s cubed. It continues in that order. And so when you compare the two, you realize that 1 is the same 1 here, x is the same x here, but n is now minus 2. So wherever you see n in the formula, you now substitute that by minus 2. And that's what we have done here. So 1 plus nx, n is now minus 2. So it's 1 plus minus 2x. Then we have plus n, that is minus 2. Then n minus 1, so minus 2 minus 1 over 2 factorial. Don't forget that we have x squared here. Then plus n, and n is minus 2. n minus 1, that is minus 2 minus 1. N minus 2, that is minus 2 over 3 factorial, then s cubed. Then we simplify. So minus 2 times x is minus 2x. So we have 1 minus 2x plus. Then we have minus 2 here. Minus 2 minus 1 is minus 3. Then we have our x squared here over 2 factorial is 2 times 1 plus we have our minus 2 here. Minus 2 minus 1 is minus 3. Minus 2 minus 2 is minus 4. All divided by 3 factorial is 3 times 2 times 1. Then we have our x cubed. So we simplify. 1 minus 2x. Then minus 2 times minus 3 is 46. So we have 6x squared all divided by 2 because 2 times 1 is 2. Then minus 2 times minus 3 is plus 6. Then 6 times minus 4 is minus 24. So minus 24x squared minus 24x cubed rather divided by 3 factorial is 3 times 2 times 1. That is 6. So a step down by simplifying, we have 1 minus 2x. Then 2 goes into 6 3 times. So we have 3x squared minus. Then 6 goes into 24 4 times. So we have 4x cubed. So this should be the expansion for the first problem. That will be the expansion for the first problem. So I advise that you take the video back, take your time, get your book, your pen and calculator, and you follow what I have done. You will understand it better. Now we see how best we can solve the second question. We see how best we can solve the second question. Now the second question is the same approach. So we are going to use the same formula. We are going to use the same formula. So the formula is still on the board. But the question is 1 plus x exponent 1 on 4. So when you look at this, you can also see that, don't forget, we are expanding as far as the term in s cubed. And so when you compare the two, the 1 is 1 here, x is x here, but n is now 1 on 4. So wherever you see n, we now substitute that by 1 on 4. So we are going to have 1 plus n, and n is 1 on 4x plus n. That is 1 on 4. Then 1 on 4 minus 1 over 2 factorial. We have x squared here. Then we have n. And n is 1 on 4. N minus 1. That is 1 on 4 minus 1. Then we have 1 on 4 minus 2. Then we have 3 factorial. Then we have s cubed. Then we have to stop there. So now we are going to simplify this. We are going to simplify this. So we have 1 plus. We have 1 on 4 times x, and that will give us 1 on 4x, or x over 4 is the same thing. Then we have plus. We have 1 on 4 here. Then we have 1 on 4 minus 1. Let's simplify this so that you can understand what is happening. We have 1 on 4 minus 1. LCM is 4. 4 here, 1. 1 times 1 is 1. 1 here, 4. 4 times 1 is 3. 1 here, 4. 4 times 1 is 4. So 1 minus 4 is minus 3 on 4. So that means 1 minus 4 minus 1 is minus 3 on 4. Okay, don't forget we have x squared here over 2 factorial is 2 times 1. Okay, then now let's take this off. Let's take this off. We have plus 1 on 4. Don't forget 1 on 4 minus 1 give us minus 3 on 4. So it's the same thing. That now we have 1 on 4 minus 2. So let's try that. 1 on 4 minus 2. The LCM is 4. 4 here, 1. 1 times 1 is 1 minus 1 here, 4 times 2 will give us 8. So 1 minus 8 will give us minus 7 over 4. That means that here we have minus 7 over 4. Then we have s cubed. All divided by 3 factorial is 3 times 2 times 1. Okay. So this is simple fraction. This is simple fraction. Now we continue. We have 1 plus x over 4. Then let's simplify this. 1 times minus 3 will give us minus 3 here. Then 4 times 4 will give us 16. So we have minus 3 over 16. Don't forget it's all by 2 times 1 is 2. Then we have x squared. Then let's simplify this. Here we have 1 times minus 3. That's minus 3. And minus 3 times minus 7 will give us plus 21. So we have plus 21 s cubed. S cubed divided by 3 times 2 times 1. That will give us 6. 3 times 2 times 1. Okay, take note of this. It's very important. The numerators will multiply. So 1 times minus 3 is minus 3. Minus 3 times minus 7 will give us 21 over. Then we have 21 over 4 times 4 will give us 16. And 16 times 4 will give us 64. So we have 64 here. X cubed. All divided by 3 times 2 is 6. 6 times 1 is also 6. And so this should be 1 plus x over 4 then minus, this will be 3 over 32 x squared. If we simplify 3 over 16 all by 2, the answer will be 3 over 32. And let me show you this so that you can understand what is happening. That is 3 over 16. If you have 3 over 16 and you are dividing this by 2, don't forget that this is also 2 over 1. So this will be 3 over 16. When the division sign changes to multiplication, 1 goes up and the 2 comes down. So 3 times 1 give us 3, but the 16 times 2 give us 32. So that's how come we have 3 over 32 here. But don't forget there was a negative here, and that's the negative you are seeing. So we have minus 3 over 32 x squared. Now, plus, take note of this, that this is 21 over 64 all divided by 6. And so this will also be like this. Now let's start simplify so that you can also understand what is really happening. You have 21 divided by 64. That is 21 divided by 64 all divided by 6. But don't forget that 6 is also over 1. So this one will be 21 over 64 times, because when the division sign changes to multiplication, 1 goes up and the 6 comes down. So 21 times 1 will give you 21, but 64 times 6, here we have 64 times 6. So we multiply, you can do that on your calculator. That is 64 times 6 will give us 384. So we have 384. So this will be plus 21 over 384 x cubed. And this will be the answer for the second question. This will be the answer for the second question. So it is just substitution. That's why you just compare this with the expansion. Then wherever you see n, you now put 1 over 4. Take note that 1 is 1, x is still x. And so it is only n that has changed. So the n, wherever you see n in the formula, you now substitute that by 1 over 4. And the rest will be simplification of fractions, and the answer will be out. So the expansion for 1 plus x exponent 1 on 4 is 1 plus x over 4 minus 3 over 32 x squared plus 21 over 384 x cubed. So that will be the answer for the expansion of 1 plus x exponent 4. Now, let's see how best. I guess you understand that if you are getting confused, you take the video back, take your time, pause it, you look at it so that you can understand before you move to the next one. Now, we are looking at the I part of the question number 1. The I part of the question number 1, and we are going to look at how best we can also solve that problem.